Welcome to this explainer. Today, we're taking on the ultimate construction project. But, instead of mixing concrete or flying steel, we're actually charting the journey of building a career. Specifically, the dynamic, incredibly rigorous, and super rewarding path of becoming a civil engineer. If you've ever looked up at a towering city skyline or, say, driven across one of those massive suspension bridges and just wondered exactly whose brain powered that reality, well, you're definitely in the right place. Seriously. Think about it for a second. How do you build a city? It's a massive infrastructural challenge, isn't it? Just imagine the absolute maze of roads, the soaring high-rises, the hidden underground water systems, and those crazy resilient bridges spanning giant rivers. Our modern world, it doesn't just happen by accident. It's meticulously calculated, designed, and brought to life by specific minds equipped to solve literally some of the most complex physical puzzles on Earth.
And those minds? They belong to civil engineers. These are the professionals who design, build, and maintain the very foundation of our physical environment. And this isn't just about drawing lines on a page. This is a career with incredibly high stakes. The real-world impact is everywhere you look. When civil engineers do their job right, society functions seamlessly, and more importantly, safely. They literally build the world we live in.
Okay, let's dive into this. Our blueprint today covers 4 phases. 1. The engineering blueprint. 2. Building the educational foundation. 3. Gaining practical field experience. And 4. Achieving professional licensure.
Starting right off with Phase 1, the engineering blueprint.
So this journey is basically a direct 4-phase sequence. First, you earn a specialized degree. Next, you pass the FE exam. Then, you complete a hands-on apprenticeship. And finally, you hit the ultimate goal, passing the PE exam. Because just like every single skyscraper needs a crystal clear step-by-step plan, this is exactly how aspiring engineers get their careers off the ground.
Moving right along to Phase 2, building the educational foundation.
Now, what's really interesting about this initial phase is that your very first major decision is actually choosing between 2 totally distinct undergraduate pathways. On one hand, you have the Bachelor of Science. That one leans heavily into the theoretical framework. We're talking lots of advanced mathematics, deep physics, really understanding the fundamental laws of nature. But on the other side, you have the Bachelor of Engineering, which is way more focused on practical application, design principles, and how complex systems actually work together out there in the real world. Now, both of these are going to get you to the exact same destination, but your day-to-day college experience, it's going to feel quite a bit different depending on which angle you prefer to tackle problems from.
But hey, regardless of whether you lean towards theory or application, the rigorous skills you acquire are going to act as your permanent structural framework. You're going to completely conquer advanced mathematics. You'll master structural mechanics, learning exactly how forces interact with things like beams and columns. You'll study fluid dynamics, which is an absolute must if you ever want to design a dam or a water treatment facility. You'll dive super deep into material science, because you absolutely have to know how concrete and steel behave under intense stress. And finally, project management. Because at the end of the day, great engineers also have to lead complex teams and manage some pretty massive budgets.
So chronologically, your academic timeline maps out kind of like this. Freshman year, you're laser-focused on basic sciences. By junior year, you're picking a specific branch specialization. Senior year is basically the crucible. You prove your worth with a massive capstone design project that simulates real-world engineering pressures. And then, right post-graduation, your immediate focus shifts completely to preparing for the FE exam.
Which brings us to Phase 3, gaining practical field experience.
Right, so before you can actually get your boots muddy out in the field, you face your first real trial, the Fundamentals of Engineering, or FE, exam. Now this is a grueling marathon of a test right after graduation, and passing it, totally non-negotiable. Earning that passing score is what grants you the coveted Engineer in Training, or EIT status. It is literally the legal gateway that allows you to officially kick off your professional apprenticeship.
And this brilliantly illustrates exactly where an EIT can go to work. Because the civil engineering umbrella is huge. If you go into the structural branch, your focus is entirely on framework and integrity. You're the person making sure the skyscrapers and bridges don't fall down. Geotechnical engineers, they deal with earth and soil, securing building foundations and boring massive tunnels underground. Transportation engineers are all about optimizing movement and transit, designing the highways and railways that connect our sprawling cities. And water resources engineers handle fluid management, designing essential dams and water treatment plants. During your apprenticeship, you are going to dive incredibly deep into just one of these specialties.
And that leads us to the final hurdle, Phase 4, achieving professional licensure.
But to get there, you need to hit this specific number, 4. 4 years is the standard, absolutely crucial amount of practical experience hours you must log. For 4 full years, you're out there working as an EIT under the direct supervision and mentorship of a licensed professional. You're learning the ropes, you're making mistakes under a watchful eye, and you're finally seeing how textbook physics translates to a chaotic, noisy construction site. And it's only after logging those 4 years that you're permitted to take the final step,
which is the Principles and Practice of Engineering, or PE exam. So the crucial point here is this. Passing the PE exam isn't just about getting some fancy certificate to frame on your office wall. No way. It grants you the immense legal authority to sign and seal actual engineering plans. When a PE stamps a blueprint, they are taking on the personal and professional liability for the safety and integrity of that entire project. It's a mark of immense prestige, incredibly deep expertise, and profound public responsibility. At this point, you have officially transitioned from a student learning math to a master builder trusted by society.
which leaves us with one final thought. We've looked at the blueprints, the rigorous education, the intense exams, and those long hours of apprenticeship required to reach the pinnacle of this field. It's a demanding path, for sure, but it's also one of the few that gives you the actual power to physically shape the future of our planet. So knowing everything it takes to get there, the only real question left for you is, what will you build?